Alright, good morning, algebra students. Today we're going to do graphing and solving systems of linear inequalities. So our goal today is to graph a system of inequalities. And a system of inequalities looks like this. Two inequality statements, they each have two variables, x and y. And the solution of a system of linear inequalities is an ordered pair that is a solution of each inequality in the system. For example, 3, -1 is a solution to the system above. The graph of a system of linear inequalities is the graph of all the solutions of the system. So get that into your notes and let's move on and I'll show you what we're talking about. Alright, first this is the how-to. This is how we're going to graph a system of linear inequalities. So you need to summarize this into your notes. So the first thing you're going to do is graph the line that corresponds to the inequality. Make sure that you use a dashed line for less than or greater than and a solid line for less than or equal to, greater than or equal to. Then you're going to lightly shade the half plane that is the graph of the inequality, and you've done that before. And colored pencils are usually helpful to help us distinguish between the different half planes. But you don't have to use colored pencils, but they are helpful. So the graph of the system is the region that is common to all of the half planes. So if you use colored pencils, it is going to be the region that has been shaded with every color. Let me show you what this looks like. Alright, so here's an example of an inequality, a system of inequalities that's been shaded with red and blue. So first you're going to begin by shading the inequality. So we have y equals negative 3x minus 1. So here is this line, y equals negative 3x minus 1. And then you have y equals x plus 2. So this is y equals x plus 2. So what we've done is the actual inequality that you're shading are these. These are the actual inequalities. So y is greater than or equal to negative 3x minus 1. That's this line, so you would shade this direction. And we shade that in red, you can kind of see. And then y is less than or equal to x plus 2. That's this line, which is dashed. And so we shaded less than, which was below here. And then the solution is this area here that is what I call double shaded. It is the intersection of the red and the blue. So any point that lies within this range would be a solution to that system. So let's try doing two on our own, or two together. So you'll need graph paper. We're just going to do these two examples. And we'll do one in red and one in blue, just like them. So here we want to graph this first one, y is less than 2x plus 1. So we would go here to plus 1, and then we want to go up to over 1 and graph that. And this is a less than, so we use a dashed line, and then we're going to shade less than, so below the line. And then I'm going to use blue for the second line, so we're going to graph that at plus 4. And then the slope is negative 1/3, so down 1 over 3. Okay, and then we'll draw that line. And now that's a solid line, and it says it's greater than or equal to, which means I shade up. And so you can see the area that is the solution is going to be the double shaded area. So I'm just going to make that a little bit darker. I don't get the purple, but the solution is going to be right there. So that's how you graph it. So let's do one more for practice. Alright, so we're going to graph y is greater than negative x plus 2. So we'll start here. Negative x means I have a negative 1 slope. And the kind of line that I'm going to draw is a dashed line, so I'm just going to do a dashed line here. And it's greater than, so I'm graphing up. Then I take my other color, and I'll do y is less than or equal to 2/3 x plus 5. and I will draw it's less than or equal to, so I'll draw a solid line across. Not a very straight line, but that's okay. Less than or equal to is below here. So the area that is the double shaded area, I'm going to darken it. And you want to make it darker, especially if you're not using colored pencils, even if you are, because you're looking for that thicker shaded area, and that's going to be the solution to the system. Oops, sorry about that Facebook post there. Okay, so that's it. Another thing you need to be able to do is look at a graph and be able to write the inequality from the graph. So let me add that into this video. So let me pause this. So here is an example. You might want to draw this into your notebook. This is an example of a system of linear inequalities, and it's already graphed for us, and you can see that the solution is right here. So what the question would be is, what is the system of inequalities? You have to know the actual system. So we're going to work backwards to solve this. So the first one, we're just going to look at this line right here, and we want to come up with, it looks like it's shaded below. It's a solid line, and the equation would be, remember you do y equals mx plus b, so we're going to do less than or equal to. Y is less than or equal to, and the slope is, let's see, down 1 over 1, down 1 over 1, so the slope looks like it's negative 1x, and then the y-intercept is plus 4. So that's the first inequality, and that would be this one right here. Now I'm going to look at the next one, and let's see, we want to do y, start with y. And this time it's shaded above the line. So because it's shaded above, we're going to do y is greater than, but not equal to because it's a dashed line. And then your y-intercept is negative 2, so I'll put that here. And then I just need to see what my slope is. So my slope is up 1 over 1, up 1 over 1. So that's my inequality right here. So, and the solution would be this double shaded area. So you'll need to be able to work these problems both ways. All right, that's it for today. Enjoy your homework.